In this lecture, we will briefly compare Jasypt and JCE, Java Cryptography Extension. JCE will be the preferred way to go for encrypting our secrets. Let's see why. In terms of output, Jasypt default output is base64 encoded. But can also be set as hexadecimal. While JCE default output is by default hexadecimal. In Jasypt, if you look at the source code, using pbkdf2 is not possible to create a secret key, where pbkdf2 stands for password-based key derivation function. In Jasypt, we can only use PBE key spec without salt and iteration count, as you can see here. All of the PBE algorithms uses a one-way hashing function. However, in Jasypt PBE implementation, salt is used in encryption process directly, not in creating the secret key. However, with pbkdf2, secret key is created using a salt and then with an iteration count to end up with a slow hashing algorithm. By using a slow hash function, pbkdf2 makes it difficult to use brute force attacks. And by increasing the iteration count, this difficulty can be increased further. Jasypt approach might be a little bit faster, especially with cached single salt. Here, as you can see, we have an optimized salt option, where only a single salt is used and cached for later usages. But using a PBE key spec without salt and iteration count is less secure for sure, and more open to rainbow attacks, especially if the key is not strong enough. Rainbow attacks holds the plain text password and hash pairs in a pre-computed rainbow table and use brute force to try to match the hashed value with an input. Here you see an example rainbow table. Normally, it is more complicated than this simple table, but just to give the idea, here you see two columns in a database table. First column has the password, and the second column has the corresponding hash value. Now, when you have a hashed value and want to get the plain password, you may query this table and get the password. So, as a high-level description, we simply query a pre-computed table to get a plain text password from a hashed value. This will require brute force attack. That means you need to go over the whole table to search for a hashed value. As I said, this is a high-level description. Actually, a rainbow table has a more complex structure, like first matching the first part of a hash value, and then it goes to one level below to continue searching, but this is just to give you an idea how it works. Let's check the source code that is used in Java Cryptography extension. In AES Bytes Encryptor class, we see that it uses pbkdf2 with salt and iteration count during key generation. So I would say Jasypt is a bit easier to use, but Java Cryptography extension is a standard, which allows to use pbkdf2 and more options, and so it is more secure than Jasypt. So I will merge JCE branch into the master branch and continue from there in the next lecture. I want to remark also that we will use the same encryption process for any sensitive configuration data in our configuration files. the encrypted values in configs will be decrypted at startup by config server and sent to services unencrypted. So it is also important to use SSL TLS enabled communication in production environment. As a final note, here we are using symmetric key approach, where there is a single key for encryption and decryption. There is a superior option, which is to use asymmetric approach like RSA, where encryption is done by a public key, while decryption is done by a private key. It is easier to use symmetric approach as there will only be a single property value in Bootstrap configuration files or environment variables, as we used in our application. However, asymmetric approach considered to be more secure. If I summarize the differences between asymmetric and symmetric encryption, with the asymmetric encryption, you use two keys. One is a private secret key, and the other one is a shared public key. With asymmetric encryption, the message is encrypted with a public key and can only be decrypted using the corresponding private key. So without knowing the private key, an attacker cannot decrypt the encrypted value. This approach is slower because it has more complex mathematical logic and it uses two different keys for encryption and decryption. Actually, this is the natural trade-off having more secure or faster systems. If you want to make it more secure, it will be slower when you use asymmetric encryption because it will use more complex algorithms to make it more secure, which will make it slower. Using asymmetric approach also enables using a digital signature, which enables checking the data integrity. So apart from confidentiality, asymmetric approach provides data integrity, which will help to identify if the data in transit is changed or tampered. And finally, an example algorithm that uses asymmetric approach is RSA, which is currently used in SSL and TLS solutions on the web. With this symmetric approach, you will have a single key, which will make it faster. So the same key is used for encryption and decryption. It is faster, but as a consequence, it is less secure than the asymmetric approach. It provides confidentiality to share the messages in encrypted format. With symmetric approach, since you have a single key, it will be a challenge to share this key. You don't need to think about sharing the key in the asymmetric approach because you always keep the private key as a secret, while you can share the public key with everyone. Finally, an example algorithm that uses symmetric encryption is AES algorithm. There might be different options here actually, like sending the encrypted text to the services and leaving the decryption part to the service itself. But in that case, sharing the key will be a challenge. So among these different options, for our examples, we will be using JCE encryption and decrypt the secrets in the config server and send to microservices. So again, for production environments, remember to enable SSL TLS in the communication between config server and microservices. Alright, I will see you in the next section.